Welcome to a short video on the concept of covariation and correlation. Correlation is an important calculation in finance. It's at the heart of the modern portfolio theory. In addition, when you run regression analysis, correlation is your R squared. Let's first look at the expected return for a portfolio. Now, it's just the weighted average of the asset's expected return. Now, in this example, I invested 25% of the $100,000 into each of the four stocks. So if I multiply the 0.25 or 25% times each of the expected returns and add them up, I get the portfolio's expected return. Now, we cannot calculate or compute risk this way. Look at this section here on the screen. This is showing 2 points, X and Y. Under X are four numbers, 3, 1, 3, 9. And under Y there's 4, 4, 8, 8. These numbers mean nothing. They're just showing how to calculate covariance and correlation. The first thing I'm going to do with all the data points under X is I'm going to add them up. I get 16. That's its summation. And then I'm going to divide by the four data points, and I get 4. 4 into 16 is 4. That's the X bar. And I can do the same thing for Y. 24 divided by the 4 gives me 6, so that's the average. In addition, I'm going to go ahead and calculate, which I've already done for us. I calculated the standard deviation of the four data points under X and the standard deviation of the four data points under Y. We don't need them yet, but we will here in a moment. Next, I'm going to go ahead and calculate X minus the X average. In this case, X minus the X average. So 3 minus 4 is a negative 1. And I'm going to go down here and do for each one of these. That's the X minus the X average. I'm going to do the same thing for Y. This would be the Y minus the Y average gives me this number. So 4 minus 6 gives me negative 2. And I'm going to do it for the other three data points. This column is the multiplication of X times Y. So X negative 1 times a negative 2 gives me a positive 2. And I'm going to do it for each data point. And then I'm going to add them up. 16 is the summation of X and Y, or the product of X times Y. Now here's the covariation. The covariation is X of XY is the summation of X times Y divided by n minus 1. What is n minus 1? Well, n would be four data points, so 4 minus 1 would be 3. So 3 into 16 gives me 5.333. Now, why did I divide it by this? Because this is not a population, it's just a sample. Now, this is the covariation of two data points. Earlier, in earlier videos, we did the variation. The variation was an interesting number because it was not in the units. Therefore, in order to get the variation into a number that we could use or understand, we had to take the square root of it, and we called that the standard deviation. In this case, the covariation is actually in the same units, but it doesn't make a lot of sense to us. So what we have to do now is divide the covariation of these two data points by the multiplication of the product of X times Y of their standard deviation, or in most textbooks will say sigma times sigma. Of course, this is not sigma because we're not dealing with population. This is just a standard deviation. So if I multiply the standard deviation of X times the standard deviation of Y, I get this number here. Therefore, if I divide this number into this number, I get its correlation. So let's go ahead and do it here. Equals this number divided by this number, and I get a 0.666792. Let's go ahead and do it one more time, but let's use the Excel's version of correlation, which is right here, C-O-R-R-E-L, correlation. And I'm going to grab these data points here for X and these data points for Y, hit OK, and we get approximately the same number, a little rounding error here. And that's just correlation. Now, generally, correlation is a number that falls between a -1 and a 1. 0 would be the fact that these two numbers have absolutely no correlation. When one does something, the other one doesn't do anything. If I were to graph a scatter plot, it looks like I've taken a sponge and soaked it into ink and thrown it against a wall. If it starts to approach 1, it shows me the strength and the direction of these two data points are are going in the same direction. For instance, the hours studied and the grades a student receives. If the two data points are moving in the opposite direction, maybe it's the amount of alcohol a student consumes and their grades would go in opposite directions, that would be a negative correlation. It would be approaching a negative one. So this number shows me that it's not a real strong, more of a moderate correlation when one goes in one direction, the other one goes in the same direction. Now let's look at these two columns. We'll call this investment A and this investment B. These are the returns for investment B at various times, maybe, and this is the return for investment B in various times. Let's go ahead and look at its correlation. I'm going to populate this Excel cell and go ahead and hit statistics and correlation. And I'm going to grab these for the first set of data points and this for the second set of data points. And now what we have here is a negative one, which means they're negatively correlated. When one goes in one direction, the other one goes in the opposite direction in strength. Now this is what we do in modern portfolio theory. We like to try to find stocks that are not correlated. If I pull down here, this is kind of what we see. If we look at Altria and Amgen, we have two companies, and that red line would show there is a strong correlation between the two. So what we attempt to do in modern portfolio management is find stocks that are somewhat not correlated or maybe negative correlated, and then we can pull that red line here to the direction it becomes blue and then black, and if we look, we have lowered the risk while increasing the return.